I want to thank everybody for joining us today for Asterisk Technology Group's partner webcast series. Today's session, The Digital Laboratory, What the Future Holds, is going to be presented by Citara. So we're going to have them come on in just a moment. We can go to the next slide, please. Today's presentation is entitled Orchestrating Digital Transformation in the Scientific Laboratory. So Scitara is going to be presenting to us today. We're thrilled to have them on, and I know you're going to really enjoy today's presentation. Before we get into that, we'll just do a couple of quick slides about who Asterisk is and a little bit more about why we're putting this this webcast series on. So we can go to the next slide, please. Okay, so real quick, before we transition over to our guest speakers for today, a quick introduction into who Asterisk Technology Group is. We're an informatics and professional services and staffing company dedicated to servicing the scientific community. A couple of quick stats. We were established in 1995, privately held company. We originated in the IT division of APBI, which was a $300 million life science research organization. Today, we operate in 7 offices in the United States and Costa Rica, and we are headquartered in beautiful Red Bank, New Jersey, and we have just about 800 employees. We target Fortune 1000 life science enterprises, chemical, CPG, government, research institutions, all which tend to have large and fast-growing IT and outsourced and compliance needs. Our mission is and always has been to deliver scalable, sustainable solutions for the scientific community. We can go to the next slide, please. So real quick, the group that's putting on this session is the Asterisk Professional Services Group, and this group is responsible for the end-to-end services which span the complete life cycle of scientific data systems. This is everything from business process analysis and enterprise architecture, which is essentially our team coming in and helping a laboratory understand what technology needs to be put in place and how that technology should be architected. And then from there, we also provide services that help select laboratory vendors, and then ultimately we do things like develop and implement that technology. Ultimately, we can provide post-implementation support in the form of computer systems validation, as well as laboratory system services, and even scientific and technical staffing services. Ultimately, we help evaluate, implement, and manage systems to enhance the collection and processing of scientific data. Let me go to the next slide, please. So with that, I want to go ahead and introduce our speaker for today, Dave Levy. He's the head of product management at Citara Corporation. He brings 30 years of product management, global account experience at leading technology companies, including Waters, New Genesis Technologies, Cambridge Soft, and PerkinElmer. He brings a master's in geology from the University of South Carolina and a BS from University of Louisville. So Dave, I'm going to go ahead and pass it over to you.
All right, thank you very much, Kevin, and welcome to everybody who has joined the call. Thank you for joining us this afternoon. So it's my pleasure to talk a little bit about Citara Corporation and Citara Digital Lab Exchange Platform. Citara is a global provider of cloud-native software, and really our focus is looking at the way instruments, software, and other resources in general in the laboratory interconnect and work together. What we have observed is a series of challenges that face the laboratory and the science-based markets. And they are multidimensional, really. The industry itself has a challenge in realizing the true benefits of digital information. I think just to work, just about everyone has some sort of a digital transformation initiative. And it revolves around the need to speed up access to data, the need to more freely exchange information. And quite honestly, we see that the lack of ability to easily exchange digital data, particularly result data, in our experience, is really hindering and holding back the advancement of science. And there's a number of challenges that create problems here, and a lot of them are very just generally broad-based. First of all, there are a number of point-to-point integrations that are possible. And we'll talk a little bit as we go forward that really to connect any 2 points from an integration point of view between 2 instruments or an informatics platform and another instrument, it's not very hard. The tools are there to do it, and it can be achieved. But there's a real challenge when you look at the lab holistically and you look at the kinds of the kinds of digital exchange that need to happen both between instruments as well as between instruments and informatics applications, and the ability to maintain those integrations can be very challenging, especially if you have a lot of bespoke point-to-point connections that have to be handled and tend to be customized. Instrument and application vendors really are equally burdened because they have the challenge of maintaining and managing individual integrations. And quite honestly, from a business point of view, it can be very difficult for any vendor to advocate for investing time and money to integrate between two laboratory resources when they're not part of that integration. And so you wind up with a patchwork quilt, depending upon which vendors you're working with, where certain vendors have integrations with certain systems that they consider strategically important, and other vendors have integrations with other systems that they consider strategically important. And yet those integration strategies are segmented, they're siloed, and there's no holistic approach to exchanging data within the laboratory. And so with that as our backdrop, let's kind of dig in a little bit further into the role we play at Citara with our digital lab exchange platform. So there's a couple of ways of thinking about the lab that we're trying to change. And here is an example in an analytical lab of some of the typical applications that you might find. And across the top, you see some of the standard informatics applications like SDMS, LIMS, eNotebooks, et cetera, data lakes. And across the bottom, you might see instruments. You see some of the standalone instruments like balances, pH meters, standalone PC-based instruments, enterprise instrument systems like the HPLC systems, like Empower, Chromeleon, for example, OpenLab, and as well as, of course, of streaming data systems in the bioprocess space. And what people very commonly tend to do is think of the resources at the bottom as data generators and the applications at the top as data consumers. And one of the things that we're looking to really change in terms of the way people think about these is to eliminate that kind of concept and realize that they're all data consumers and they're all data generators and they all exchange data with each other. The second is this concept of point-to-point communications. And I mentioned before that for any two systems to integrate with each other, the technology is there, and it's honestly not that difficult. So you can go ahead and establish one connection, and that's great, and then you might establish another connection, and that's fine too. But once you start looking at all of the different combinations of integrations that are needed, you very rapidly create a mess, and it's very difficult to manage. It can be very expensive to manage, and it creates a real challenge in terms of moving data around in any kind of efficient way. What also happens as a result of this is that instruments get left behind. So there's a prioritization where you might say, well, I really want to interface between my LIMS and my HPLC system, but maybe there's some standalone PC systems over there or some balances over here that the activation energy, if you will, or the difficulty to get there is just too high, and you just don't want to deal with having to maintain and handle that over time. And so that's the challenge. And what we are looking to do is really, as I said, change the way that is looked at really from the ground up. And the first way to do that, in our opinion, is to establish a platform holistic communications channel. So let's first address the point-to-point concept. In the Citara DLX world, there is no point-to-point. Everybody is a peer. Each application or instrument or even resources like a Box or Office 365, OneDrive, they're all resources. And they're all peers on the network. And because they are peers, instead of point-to-point communication, you establish a peer network where all you have to do is connect into the network itself, and you immediately have access to all of the other instruments and resources that are out there on the network. And this creates a much more manageable process in terms of being able to do two things. Number one, establish a consistent communications protocol between all of the resources, the digital resources in your lab, as well as simplifying the way that those connections are maintained and handled over time. And finally, an environment exists where you really don't have to leave anything behind. You can really communicate and connect all of the resources in your laboratory into a platform like this, and you don't wind up having to pick and choose and leave instruments off of the of your digital network. And this then facilitates a much more freely and open flow of communication between all of these different resources. And it also gives you the flexibility to change your workflows, to add new instruments, and to change the dynamic of the laboratory. And depending upon the kind of laboratory you're in, this can happen a lot. If you're in an early stage discovery development lab, you might be moving things around all the time and reconfiguring. If you're in a QC lab, you might have a more stable environment, but you still, when you look at the broad base of digital communications that are going, you're not just communicating instruments with LIMS. You might want to communicate those instruments. You might want to send, for example, weight data from a balance directly to a chromatography system in addition to the LIMS to provide more efficient workflows. So we're really looking to enable that flexibility of really sending data wherever you need to send it and receiving it on time in the right format and in the right place. So how do we do this? The Citara Digital Lab Exchange really has three fundamental principles that all of this is based on. And the first is the connection platform. And you see our motto, no instrument or application left behind. We'll talk a little bit more about the connection platform as we go forward, but the objective here is to create a connection platform that allows us to react very, very quickly and very efficiently to onboarding new communications. So typically from the time that we are approached by a customer to build what we call a connector for an instrument, generally it takes us 1 to 2 weeks to do the technical work. In some cases, a couple of days. It really depends upon the complexity and the sophistication of the instrument. The reason that we're able to do this is because 75 to 80% of all connectors are exactly the same. We're building all of the infrastructure into the connection into our platform that is consistent across all of the different applications, all the different connectors. The only thing we have to change from connector to connector is learning about that particular resource, what kind of data is available, how do we get access to it, etc. And we are working very, very much so with partners in the industry to partner with them and provide connectors for as wide a range of instruments as possible, as well as software applications. The second piece of the puzzle is what we call the orchestration engine. So having established the connections to all the endpoints, the ability exists to provide business rules with regards to where the data needs to go and what are the conditions. So event-driven lab workflows, for example, the ability for a LIMS or any notebook to actually submit a request for analysis, that is considered an event. That might trigger a cascade of activity, including notifications to end users by way of email or text that there is activity that needs to be done. Let's say a balance weight needs to be taken. It might include the creation of a sample queue in an HPLC system, including the ability to take those weights, and we'll talk about how we do that with simple instruments in a minute, but navigate a way to take instruments that don't have PCs, even manual readings for dials and things like that, and bring those into the digital world. We do also have the ability to provide calculations and logic for data in flight. So if data is coming off of an instrument and certain mathematical rules need to be applied, if you want to apply rounding rules or you want to perform a mathematical operation on the way to its ultimate destination, you can do that. And all of that information is captured in our audit trail. All of the transactional information that flows through our system is captured and can be reconstructed at any time. And what this allows you to do is create these workflows that are automated but actually have gates. So you can send the workflow through an automated process, stop it for review, and then upon review, it can continue on its way. And as all of this is happening, the Citara DLX system is monitoring the process of the activity in the laboratory. So you can gain a sense of where you are. If you, for example, are waiting for a certain activity to happen, whether it's a review of data or a measurement to be taken that involves manual interaction, and nothing has happened for 3 or 4 hours and it should have happened within 5 minutes, you'll be able to set up notifications to enable that and remind people that they need to do things. So there's the actual status of an orchestration, but there's also the ability to monitor, as I mentioned, the digital data that's flowing through the system. So we're providing the ability not only to track the data itself in flight, whether it's been processed or not, so you can see the original data as it was captured at the instrument. If you want to perform any mathematical operations on it, you can see what those operations are, you can see what the result was, and then you can see where it went. And all of this can be reconstructed, as I mentioned, which gives you a very strong regulatory and data integrity position for data in flight, which is something that now is becoming, as we try to perform this digital transformation in the laboratory, what happens to data in flight is going to become that much more important. So let's take a moment to dig into some of these different areas. First, regarding the connector technology. So there is a whole universe of instruments, applications, and services that are out there. And the diversity of equipment and resources that are being used by the lab changes all the time. And this is one area where we see, a real benefit to a technology like ours that can respond to those changes, can respond to that flexibility, and very quickly add new devices. We are planning, as we roll out Citara DLX, to also open up the framework for third parties to create connectors as well. And we will be publishing some of the core connectivity capabilities and establishing a connector community that is available for third parties to build their own connectors. And we'll be working with them to establish testing frameworks and things like that, similar to some of the other application portals that are out there today. Now, when we look at the different kinds of connectors, as you might have seen from the earlier slide, we tend to break them down into 4 segments. The first being simple device connectors. These are connectors that typically do not have a PC involved. There's no PC connected to them. They can include things like balances, pH meters, particle counters, titrators, for example. In some cases, we still have talked to customers that are reading dials off of instruments that, there's not even a serial connection. To support these instruments, we have an IoT device for the ones that at least have a serial or Bluetooth connection. And the idea here is a connection between our IoT device and the instrument. Let's say it's a balance, where a user can go up and actually scan a QR code that's on the IoT device. They are prompted to log in, and that QR code is paired with the device. There is a link, a hard link between that QR code and that device. And you can operate the device through a tablet. So that would be what you would use to scan the QR code. This allows people now to log in, establish credentials, take a measurement, even add a picture or a manual note that gets captured along the way. And then that data can get routed to its next destination, whether it's to an HPLC or LIMS or multiple places. You can send that data in multiple directions. That IoT device is a way that we can bring those instruments into a more controlled world, because we are requiring credentials to be established before you can take a measurement. And we are capturing information and allowing you to store it and then reconstruct it, and providing the ability for actually taking pictures, and the date and time of those pictures is also saved, and that becomes part of what we call the event stream. Instrument application connectors, there's a list of applications that I'm sure you're probably quite familiar with. Most of the HPLC vendors that are there, as well as other applications for standalone PC-based instrumentation. We are focusing on driving towards API-based connections wherever we can. That said, there is still a lot of file-based data transfer going on in the laboratory. And so we have a very sophisticated data file capture and parsing capability built into our system, and that allows us to really communicate with just about anything that supports file transfer, whether it's an instrument application or a LIMS or any notebook. It's also a very quick way for us to get started and build out with our customers sophisticated orchestrations that then can be migrated over time from a file-based orchestration to more of an API-based orchestration as we build in the necessary API connections that are required. So the application file connector and the informatics file connector that you see right below are really very similar in nature. They are effectively resources and ways that we can communicate with instrument systems or informatics systems like LIMS, eNotebooks, using these file exchanges. And transforming the files in terms of formatting is a huge part of what we do. So as the data comes off of an instrument, let's say, if it needs to be formatted into a particular way in order to be ingested properly by the LIMS, that's part of the work that the Digital Lab Exchange provides. Now, a lot of web service connectors are out there as well, and there's really interesting opportunities around the web services. So as services like Office 365 and Box, some of the Google apps, although that's generally more on the consumer side, but as more of these cloud-based services become available, it opens up interesting opportunities around using these cloud services for more secure exchange of information. So you could create, for example, a OneDrive account that is not tied to an individual, but is tied to a laboratory, let's say, or is tied to a particular process. And very few people have access to that account beyond anything but read-only. And we would be able to look into that account to pick up files that could be synchronized with files on local machines so that you have backup. There's some very interesting possibilities around some of these web services that we have connections to as well. And this includes tools like Excel 365 as well. So between all of these form up the different connectors and endpoints that make up our connector library. And that library continues to grow just about every day. Now, we talked about orchestrations and having established those endpoints. The idea with orchestrations is to bring the endpoints together into a linked set of instructions that an end user can create. The goal here is really twofold. On the one hand, the great majority of orchestrations, the idea is with a little bit of training, pretty much anybody can do it. There are tools available that take more complex mathematical operations and make them simplified and packaged up. But for those who really do want to get into it and do more sophisticated things, we do have a scripting engine built into the orchestration engine that allows you to actually write JavaScript inside of the system itself. And that allows you to do more sophisticated activities. And all of this, of course, is controlled by access rights and whatnot. So the ability to create and use an orchestration could be completely different. You might have access to an orchestration and be able to run it and participate in the workflow, but not necessarily to create it or to edit it or change it in any way. So as an orchestration is in fact executing, the user community can see it working. So orchestrations in our system tend to flow from left to right. You can see here, example orchestrations on the left that are available, and then orchestrations that are actually running in the list. And this gives you visual confirmation of what's happening in the lab. So some orchestrations might happen and be fully executed in a matter of minutes or seconds. Others that involve, let's say, an orchestration that we talk to our customers about all the time. Let's say a LIMS request for HPLC analysis. That also involves maybe a balance step. That orchestration to fully execute, depending on how many samples need to be weighed and then sample prep done and the actual HPLC analysis done, by the time that data makes its way back to the LIMS, it could be multiple hours. And so you can see the status of the orchestration as it's progressing on the screen, and you can also see if it's failed. there are any number of reasons why an orchestration might fail in the laboratory. And the sooner you know that there is a problem, the faster you can get it resolved. So being able to leverage tools like this to give you the status of particular instruments, are they online, are they offline? Is my experiment running as I expected to, or is there a problem? The more information we feed the people in the laboratory that are doing the work, the better off we are. And this is also exemplified by the notifications capability, which you see in the lower right-hand corner. Our ability to send, for example, results as file attachments to be reviewed, or notifications to specific user groups that they have an action to perform or data that they should look at, or even just to provide a status that says, hey, this particular step in the orchestration is complete. Whatever you think as end users is important for your scientists to know, you can communicate to them and give them that guidance. And it also gives you the ability, as I mentioned earlier, to take what is an automated process, but break it down into more logical steps, where instead of just letting it ripple through to the end, you might want people to be looking at the data periodically and making decisions on that data as you go through. And this technology allows you to do that. So to give you a kind of a high-level sense of some of the different types of orchestrations that we've been working with customers on, simple device orchestrations, we've had customers and actually created example orchestrations for them based on their data that involve very straightforward, a LIMS request for balance weights. Multiple different sets of weights need to be taken. There's some calculations that need to be done along the way. The weights are done in triplicate. There's some averaging that goes on, maybe some subtracting for tare weights and dry weights versus wet weights, and then back to the LIMS it goes, but it has to be delivered in a particular format for the LIMS to be able to import it properly. The same can be said for file-based LIMS round trip for simple devices, well, not simple devices, excuse me, but PC standalone devices like ammonia analyzers, or any PC-based device that really, it's not a networked system, it's a standalone PC. And then the one that's one of the most common that we've worked on multiple occasions is, as I mentioned, requests from LIMS or eNotebooks for chromatographic analysis, whether it's Empower 3 or Chromeleon. It could be virtually any LIMS or eNotebook, and here there's multiple steps, and the data is flowing in multiple directions. And so we leverage the notification capability quite a bit, because we're notifying people that a request has been made and there's work to be done. As different steps of the orchestration complete, we're routing information about the completion of that step along with the data itself, letting people know what's happening. And you can see on the right-hand side that as we go through this process, we are accumulating information in what we call the event stream. And as the orchestration proceeds and more data gets captured, all of this data is now handled and managed in our audit trail, and it's handled in context. So we know what orchestration it's a part of. We know when that orchestration was executed, when it was run. And you can query the event stream looking for information in a wide variety of ways that will give you confidence that you understand how data is being moved from point A to point B, when it was happening, what were the different steps that were involved. So to give you another sense of a different kind of orchestration that we recently participated in, we were selected to participate in something called the Testa Challenge. The Testa Center in Uppsala, Sweden is a bioprocessing center, and they organized this challenge to look for innovative tools and technologies in the bioprocess space. And we were very fortunate to work with a number of young innovative companies, as well as the Testa Center and Citara, that's one of the sponsors of the Testa Center. And we were selected to provide the data backbone for the entire bioprocess. And the idea here is that we were going to capture data from a wide variety of different sources and route that data from an aggregation standpoint for the entire bioprocess to a number of different places, both to an Excel spreadsheet and to an IBS eWorkbook cloud platform. And as we worked through this process, it really gave us an opportunity to test out the model that we were putting together around connections. So we were, the kickoff for the challenge after we selected was about 2 weeks before the challenge itself actually took place. And in that time, we built a connection, we built a web service connection for the @Spiro team that had a shaker flask, file-based connections for the FreeSense and the Argus I teams. We built OPC connectors to pull data, streaming data directly out of the bioreactor, as well as from the Cytiva Unicorn system, and file-based connectors that we're still working on, in fact, with the Gyros protein technologies and the Agilent size exclusion chromatography system. So we were able to put these together in a matter of about 2 weeks to go through the tested challenge and prove that we could actually aggregate and capture all of this information. So it was a great test bed, generated a lot of really interesting data. And in fact, they're still processing a lot of that data over at the Testa Center as we speak. But it's a great example of a multi-point orchestration that involves a lot of different kinds of instruments, different kinds of data, and different mechanisms to be able to reach out and communicate with that information and then route it to a target destination. So finally, as we wrap up with regards to the web console, you know, the goal of the Citara DLX system is really not to become the center of the laboratory from the end user's perspective. We see the web console as being a primary place where people are going to go and they're going to set the system up, they're going to configure their orchestrations, but it's through the connections that you actually initiate an orchestration, or by dropping a file in a folder that we happen to be watching. That's considered an event as well. And so for the general user in the laboratory, we fully expect that they won't see the Citara web console very much. Their primary interaction with us is going to be through notifications that they get for orchestrations that are actively running. But for administrators to be able to go in, log in, look at all of the connections that are active, be able to see what's active and what's not. You can see an example on the right-hand side of the kind of data that we're capturing in the event stream and be able to interrogate that data, not just from a broad base of querying a big database, but also by investigating individual orchestrations and being able to look at the data that's captured in each step as you go through. That can be extremely useful, and that's a big part of the monitoring process. And so to wrap up, we see some real advantages to leveraging this technology. And it's important that, you know, people realize, and one of the reasons that we are getting some very positive feedback from a lot of prospective partners in the informatics space and the instrument space is because we're really occupying kind of a unique place. We're not an instrument. We're not a traditional informatics system. We are effectively like digital plumbing, essentially, and we give the ability for a lot of our partners to focus on more of the core features and functionality of their applications, and less on worrying about how to integrate with different instruments. And so we see this as a great way to future-proof a laboratory. Once you establish the digital lab exchange platform, it's easy to add new technology. It's easy to swap out instruments back and forth if you need, or change workflows. And it gives you the ability to really choose best of breed applications without worrying about compromising. On the orchestration side, that event-driven productivity is really powerful. I mean, it gives the researchers and the scientists in the laboratory the opportunity, instead of having to go and check on different aspects of experimental work during the day, they can rely on the system to actually reach back out to them and tell them when it's time to do something. So you can maximize automation. You can still control what's happening in the lab with end user guidance. You can mix and match connected systems by changing and editing orchestrations at will. It's a very cost-effective way of handling and managing the diversity, the natural diversity in the lab. And then finally, from the monitoring side, kind of starting with that end-to-end digital compliance. As I said, we're focused primarily on result data, That's really where we see a lot of our customers struggling and what our customers have been telling us they really are looking for. Not that we can't work with raw data, but that the raw data exchange tends to be a different kind of solution. Here, we're really focused on moving those results to the location that they need to be in the format that they need to be at the right time. And to make sure that there is compliance for data integrity wrapped around that exchange. In addition, the ability to just manage and monitor workflows and understand how the laboratory is operating gives our customers the ability to really look at the laboratory and look at the workflows in the laboratory in a completely different way than they have up to this point. And so with that, I'd like to thank you again for your time and attention. I'm happy to take any questions if there are any. Kevin, I'll turn it back over to you.
Great, thank you very much. We're going to go ahead and stop the recording.